Here I will show how to use the calculator to find the vertex of a quadratic function. One important thing to note is that the vertex of a quadratic function will either yield a maximum value or a minimum value for the function. And that of course depends on whether the parabola, the graph of the quadratic function, opens up or down. Let's use the calculator to find the vertex of each function. I have the function f of x is negative 2x squared plus 7x plus 10, and the function g of x is 1.25x squared plus 15x minus 50. I will use, first, f of x is negative 2x squared plus 7x plus 10. So I will go into the y equals screen and input the function negative 2x squared plus 7x plus 10. Now, I know that since the lead coefficient, since the coefficient on the x squared term is negative 2, that the parabola will open down. That's what I expect to see when I graph this, and I'm going to graph this from the standard window. Negative 10, 10, 1, negative 10, 10, 1. I graph this. I see a parabola. I see it opening down. I don't see the vertex. I don't see that highest point on the curve. So let's adjust the window settings. It looks like I don't need to adjust the x's. I need to adjust the y maximum. I need to see a little bit higher on the screen. So let's adjust the y maximum. Let's change the y maximum to, how about 30? And regraph it. And now I can clearly see the vertex. Notice that the vertex is a maximum point on the curve. So let's go to the Calc menu by pressing Second, Trace. Second, and the Trace button brings up the Calc menu. And remember that the vertex in this case is a maximum point. So I will go to the fourth option, Maximum, and press Enter. Now the calculator asks for a left boundary, a right boundary, and then a guess. For the left boundary, I want to input an x value that's to the left of the vertex, but not too far away from it. So now reading this, it looks like the vertex is near x equals 2. It's close to that. So I'm going to think to the left of it. So I can type in 1 and press Enter. And that is certainly to the left of the vertex. Now it's asking for the right boundary. I want to go to the right of the vertex. I'll type in 3 and press Enter. And then for a guess, somewhere in between left boundary and right boundary. Or I could use either the left boundary or the right boundary. So I'll type in 2. That's between 1 and 3. I'll type in 2 and press Enter. And it outputs the vertex. Notice that it's approximated, but 1.749987. I think that probably means 1.75. And then the y coordinate of the vertex is 16.125. So that was one way to use the command. Another way would be to use the cursor. So let's regraph this function, and I'm just kind of starting back at x equals 0 because that's where it would have started. Alright, so instead, if I press Second in Calc and I bring up the the maximum command, the fourth option. So now I can use the cursor. I can trace along the curve and say, well, I think the vertex is near this point. That looks about right. I move the cursor to the left a few places, hit Enter. I move the cursor to the right. I go past where I think the vertex is a few places. I hit Enter a second time. Then I move the cursor back towards the middle where I think the vertex is, and I hit Enter a third time. And again, it gives me an approximation for the vertex. Again, 1.75, 16.125. So So now would be a great time to pause this video and try to find the vertex of the second function. G of x is 1.25x squared plus 15x minus 50. Alright, so again the process would be, let's start from the y equals screen. I'll clear out the old function, and I'll type in the new function, 1.25x squared plus 15x minus 50. And let's graph this again from the standard window. I'll just change that y maximum value back to 10 to see what the graph looks like from the standard window. And I don't see very much. I see part of the curve. I know the curve's going to be, the parabola is going to be opening up since the lead coefficient is positive. Now, one other thing that's important here is notice that if we know a little bit about this, if x was 0, I see that the y-intercept would be negative 50. So I know that the curve's going through 0, negative 50. So let's adjust the window so that I can at least see that the y-intercept at negative 50. I'm even going to go a little bit past that. Let's set the y minimum to, how about negative 70? I think that's a good guess to start with. And let's change the y scale to tens. So that way we only have a mark every 10 units on the y-axis. So now this is a better graph. I see more of the curve, but it looks like I need to change the y maximum, the y minimum even more, and I think I'll also need to change the x minimum, right? I need to see more to the left, and I need to see more to the bottom. So let's change the x minimum to, how about negative 20, and let's change the y minimum, how about negative 120, and let's see if that gives us a good picture. Now that's a good picture. I can see all the important features of the curve, the x-intercepts, the y-intercept, and the vertex. So now I'll calculate the vertex. Since the parabola is opening up, the vertex is a minimum. Second, calc, minimum. That's the third option. Hit enter. So now, it looks like the vertex is around here. I've moved my cursor to about negative 6.27. It's around there, so I'm going to move to the left several places and hit enter. Then I'm going to move my cursor to the right. I'm going to go past where I think the vertex is by several places. Hit enter a second time. Move my cursor back towards the middle where I think the vertex is. Hit enter a third time. And so it looks like for g of x, the vertex appears to be negative 6, negative 95. So that shows how we can use the minimum or maximum command to find the vertex of a quadratic function.